Hey guys, welcome to our last section of Chapter 3, which is called 3.5, Solving Nonlinear Systems. So our learning target is, I can solve nonlinear systems of equations algebraically using substitution and elimination. Now those words should be very familiar because we have solved systems of two linear equations with both those methods. Now let's take a look at what nonlinear equations are. For our purposes, we will only be solving systems of equations that have either one linear and one quadratic, or two quadratic equations. And if you remember, systems of equations have solutions. Now, their solutions represent the point or points where the graphs intersect. So if we have a parabola and a line, we can see that they may never intersect, which would mean no solution. They might intersect once, which means that line is going through just one point on the parabola, so one solution, or they could intersect two times, so two solutions. Similarly, when we have two parabolas, you could also have them never intersecting for no solution, intersecting once for one solution, and intersecting twice for two solutions. Now, we can find those graphically if we would graph the two equations on our calculator, but we're going to start by finding them algebraically. So in this video, we are going to be solving nonlinear systems using substitution. Okay, solve each system using substitution. Express solutions as ordered pairs x, y. Remember, when we use substitution, we need to have one of our equations solved for a single variable so that we can substitute what it is equal to into the other equation for that variable. Now, when we are solving nonlinear systems, we always want to solve for y. So let me make that note here. Always solve one equation for y. Now, the reason I'm doing that is because usually our quadratic, has an x squared. And it would be very difficult to solve for x when we could have an x squared term and we have an x term. So it's much more easy and it'll work out much better if we just solve for y. So let me take a look at my two equations. I have x squared plus x minus y equals -1 and x plus y equals 4. I think the second one will be easier to solve for y. So to do so, I'm going to subtract x. So I will have y equals, and I like to put my x before my constant, so I'm going to write -x plus 4. Okay, now I'm going to take this expression, -x plus 4, and I'm going to put it in for y into my other equation. Now it is very, very important that you use parentheses. So I have x squared plus x minus. Now let me use a different color so we can see exactly what I'm substituting in. -x plus 4. Then I have equals -1. And now I have just x's in this equation, so I can solve it much more easily. First, I need to distribute this negative into the parentheses. So I still have x squared plus x, but this changes to a plus x, and this changes to -4, equals -1. Now I'm going to combine like terms on the left. This is x squared plus 2x minus 4 equals -1. Now I have a quadratic equation that we've been solving quite a bit. I could complete the square here by adding 4 over there, but that's probably not one of our favorite methods to solve. Let's see if we can factor this. And remember, to factor, I need to have it set equal to 0. So I'm going to add 1 to both sides, and I get x squared plus 2x minus 3 equals 0. And sure enough, this is a pretty simple one to factor. I could factor this to x plus 3 times x minus 1. Because remember, when we multiply that back, I'm going to have x times x, which is x squared. And then I'm going to have x times -1, which is a -1x. And then 3 times x, which is plus 3x. And that gives me my positive 2x. And then the 3 times -1 gives me the -3. So that is factored. And now remember, to solve, I need to set each of those factors equal to 0. So what makes x plus 3 equal 0? What makes x minus 1 equal 0? That would be -3 and positive 1. Now, because this is a system of equations, I just have the x coordinates of the 2 points of intersection of this line in this quadratic parabola. So to find their y coordinates, I plug them in. I'm going to plug them into this second one that's already solved for y. So y equals a negative x, I'm plugging that in there, plus 4. So this would actually be a positive 3 plus 4, and that's y equals 7. So this first point of intersection, I put in the x value of negative 3, and I got the y value of 7. That's one solution. My other solution, when I put in 1 in there, y equals negative 1 plus 4. That's negative 1 plus 4, which is 3. So that point is 1, 3. So this particular system had two solutions. There's 2 points of intersection. One of them is at negative 3, 7, and the other one is at 1, 3. Okay, I'm going to do the next 2 examples in the next video just to ensure that I do not get cut off.